students, myself Henasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of sequence and series. So let us begin with the first topic, that is absolutely and conditionally convergent. So a series UN is called absolutely convergent if series mod UN is convergent, that is the series of positive terms should be convergent. Okay. Next, the series UN is conditionally convergent if the series UN is convergent but mod UN, that is the series of positive terms, is divergent. Then our series is known as conditionally convergent. Okay. Now, if the series UN is absolutely convergent series, then UN is also convergent, right? Next, if the convergent series is of positive terms, means if we are given a series of positive terms and if it is convergent, then we can say that our given series is also absolutely convergent. That is, we have to check both the conditions only for alternating series, right? So let us begin with few examples. So here we have to determine absolute or conditional convergence of the series summation n is equals to 1 to infinity minus 1 raised to n into n square upon n cube plus 1. So here we are given un as minus 1 raised to n into n square upon n cube plus 1. Now we have to check absolute or conditional convergence. Therefore, we need to check the convergence of mod un. That is a series of positive terms, right? So mod un will be equals to n square upon n cube plus 1. Now we will apply limit comparison test, right? So we will take out n cube common from the denominator, right? So we will get n square upon n cube into 1 plus 1 upon n cube. Now this gets cancelled out. So what will remain? 1 upon n into 1 plus 1 upon n cube. Right? So we can assume our Vn as what? 1 upon n. Okay. Now let us find the limit of mod un upon Vn. So it will be equals to limit n tends to infinity. 1 upon n will get cancelled out. So what will remain? 1 upon 1 plus 1 upon n cube. Now we know limit n tends to infinity, 1 upon n is equals to 0. So this term will go to 0. So what will remain? 1, right? So which is a finite and non-zero number. Okay. So now again we will go to our Vn, which will be equals to summation n is equals to 1 to infinity 1 upon n. So this is a P series with P is equals to 1. So by P series test we can say that our Vn is what? Divergent. Okay. So now by limit comparison test, our series mod un is also divergent. So from this we can say that the given series is not absolutely convergent. So we have to check about conditional convergence, right? So now we will apply Leibniz test. So in order to apply Leibniz test, first condition is we have to find mod un minus mod un plus 1. So we know the answer of mod un, that is n square upon n cube plus 1. Right? Now replace n by what? N plus 1. So you will get n plus 1 whole square upon n plus 1 whole cube plus 1. Now we will simplify this by opening the brackets, right? We now take LCM and simplify. So final answer will be equals to what? N raised to 4 plus 2n plus 1 into n square minus 1 upon n cube plus 3n square plus 3n plus 2 into n cube plus 1. Now looking at this equation, you can say that this is greater than 0. That is mod un greater than mod un plus 1. So first condition of Leibniz test is satisfied. Now we will find limit n tends to infinity mod un. So that will be equals to limit n tends to infinity n square upon n cube plus 1. Now again take out n cube common from the denominator. So it will be equals to limit n tends to infinity n square upon n cube into 1 plus 1 upon what? N cube. So finally what will remain? 1 upon n into 1 plus 1 upon n cube. Again we know the limit n tends to infinity 1 upon n will be equals to what? 0. So our final answer also will be equals to 0. So both the condition of Leibniz test are satisfied. Therefore our series UN is convergent. So what we have proved? That series UN is convergent, but series mod UN is divergent. Hence our given series is conditionally convergent. Okay. Let's solve one more example. Here we have to determine whether the series summation n is equals to 1 to infinity cos n upon n square, which can also be written as cos 1 upon 1 square. Now put n is equals to 2, so you will get cos 2 upon 2 square plus and so on. So this is a series of positive terms, right? And we have to determine whether it is convergent or divergent. Now let us begin with the solution. So here you are given un as what? Cos n upon n square, right? So what will be your mod un? Mod cos n upon n square. Okay. Now we know that mod cos n is always less or equals to 1. So dividing by n square we will get what? Mod cos n upon n square is less or equals to 1 upon n square. And therefore what we have determined from this mod un less or equals to Vn. That is our Vn is what? 1 upon n square. Okay. Now series Vn will be equals to series 1 upon n square, which is a P series with P is equals to 2, which is greater than 1. Hence by P series test we can say that our Vn is what? Convergent. Now Vn is convergent and we have a condition that mod un less or equals to Vn, right? Therefore our mod un is also convergent by direct comparison test. Okay. Now since this is a positive term series, therefore we can say that our series un is what? Absolutely convergent also. Done? Now let us move on to our next topic, that is power series. Okay. So what is known as a power series? A series of the form summation n is equals to 0 to infinity en x minus a whole raised to n, which can be simplified as a0 plus a1 times x minus a plus a2 x minus a whole square plus and so on, is known as a power series in powers of x minus a, or it is also known as a power series about point x is equals to a. Okay. So here x is a variable and all the an's are constant and are called coefficients of the series. Done? Next, for example, summation n is equals to 0 to infinity x raised to n upon n factorial, which can be written as 1 plus x upon 1 factorial plus x square upon 2 factorial plus and so on, is a power series in powers of x, right? So this is an example of a power series. Now let us solve an example, that is we have to test the convergence of the series 1 upon 1, 2, 3 plus x upon 4, 5, 6 plus x square upon 7, 8, 9 plus and so on. Here we are given x is greater than 0. That is this series is a positive term series. Now whenever we have to test the convergence of power series, we will only apply two types of test. One is ratio test and other is root test, right? Depending upon our un. So firstly, let us write our un. So here un will be equals to, so firstly we will take powers of x. Firstly it is x raised to 0. Then what is x raised to 1? Then it is x square. So we are having powers of x as 0, 1 and 2. So let us find our nth term. Tn is equals to a plus n minus 1t. So only consider the powers. So a is 0. So 0 plus n minus 1 times difference is 1. So what you will get? N minus 1. So you will get x raised to n minus 1. Now again take the next series, that is 1, then 4 and 7. Similarly find Tn. So you will get the value as 3n minus 2. Then take the series 2, 5, 8. So you will get Tn as 3n minus 1, and here you can see multiples of 3. So into 3n. So finally your un is x raised to n minus 1 upon 3n minus 2, 3n minus 1 into 3n, right? Now in order to apply ratio test, we need to find un plus 1. So replace n by what? N plus 1. So you will get x raised to n upon 3n plus 1, 3n plus 2 into 3n plus 3. Okay. Now we will find un plus 1 upon un. So this is your un plus 1, right? And here we have to take the reciprocal. So it will be 3n minus 2 into 3n minus 1 into 3n upon x raised to n minus 1. Now we will simplify this, okay? So here this will get cancelled out and what will remain? X. Okay? From this take out n common from each term. So you will get n cube times 3 minus 2 upon n, 3 minus 1 upon n into 3. And in the denominator to take out n common from each term. So you will get n cube times 3 plus 1 upon n, 3 plus 2 upon n into 3 plus 3 upon n. So this n cube will get cancelled out and what is remaining? This term, right? Now let us find limit n tends to infinity un plus 1 upon un. So we have put the value of un plus 1 upon un. Now we know the limit n tends to infinity. 1 upon n will be equals to 0. So this term will go to 0, this term also will go to 0, this also will go to 0, this term will go to 0 and lastly this also will go to 0. So what will remain? 3 into 3 into 3 upon the same 3 into 3 into 3. So finally what will remain? X. So our limit is equals to x. Now by ratio test the given series is convergent if x less than 1. Looking at the condition, right? Now divergent if x greater than 1. And the test fails if x is equal to 1. So now we have to take x is equal to 1 and solve it further. So let us put x is equal to 1 in our un. So on putting x is equal to 1, you will get un is equals to 1 upon 3n minus 2, 3n minus 1 into 3n. Now in this we will apply our limit comparison test. Okay. So firstly take out n common. So what you will get? 1 upon n cube times 3 minus 2 upon n, 3 minus 1 upon n into 3. Okay. So we will assume our Vn as what? 1 upon n cube. Now we will find our limit n tends to infinity un upon Vn, that is equals to limit n tends to infinity 1 upon 3 minus 2 upon n into 3 minus 1 upon n into 3. Again these limits will go to 0. So finally what will be the answer? 1 upon 27, which is finite and non-zero, right? So now we will write our series Vn, that is equals to series 1 upon n cube, which is a p series with p is equals to 3, which is greater than 1. Hence by p series test we can say that our series 1 upon n cube is convergent. Hence by limit comparison test we can say that our series un is also convergent for x is equal to 1. So in all we can say that the series is convergent for 0 less than x less or equals to 1 and divergent for x greater than 1. Okay. Next let us solve one more example. Here we have to test the convergence of the series summation n is equals to 0 to infinity n plus 1 upon n plus 2 whole raised to n into x raised to n, where x is greater than 0, right? So here you are given un as n plus 1 upon n plus 2 whole raised to n into x raised to n. Now you can see our un is in the form of vn whole raised to n. So which test will apply? Root test. Okay, right? So we will find un raised to 1 upon n. So it will be equals to n plus 1 upon n plus 2 into x. Now let us find our limit n tends to infinity un whole raised to 1 upon n. So it will be equals to limit n tends to infinity. Now take out n common from the numerator and denominator. So you will get n times 1 plus 1 upon n upon n times 1 plus 2 upon n into x. Now again this n will get cancelled out and these limits will go to 0. So finally what will remain? X. Now applying our conditions of root test, we will get our series is convergent for x less than 1, divergent for x greater than 1, and the test fails if x is equals to 1. So again we have to check for x is equals to 1. So we will put x is equals to 1 in our un. So what will be our un finally? N plus 1 upon n plus 2 whole raised to n. Okay. Now again similarly we will find the limit n tends to infinity un, that is we will apply our nth term divergence test, right? So limit n tends to infinity, take out n common from the numerator and denominator. So n raised to n times 1 plus 1 upon n whole raised to n upon n raised to n times 1 plus 2 upon n whole raised to n. Now these two will get cancelled out and we know limit n tends to infinity 1 plus 1 upon n whole raised to n will be equals to what? E. So this will go to E and this will go to what? E square. Now cancel E out, so you will get 1 upon E which is not equal to 0. So by nth term divergence test we can say that our given series is divergent for x is equals to 1. So in all we have proved that our series is convergent in 0 to 1 and divergent in x greater than equals to 1. Okay. So in today's session we have studied firstly absolute convergence, right? So in this our given series un is absolutely convergent if series of positive terms, that is mod un, is also convergent, right? Next we have studied conditional convergence. So series un is said to be conditionally convergent if series un is convergent, right? But series mod un is divergent, then the given series is known as conditionally convergent. Okay, next we have studied what? Power series, which is given by summation n is equals to 0 to infinity an x minus a whole raised to n. For this type of power series, we will always apply two types of tests, that is ratio test and other is what? Root test. Okay. Now, if our series is of the form summation un is equal to summation vn whole raised to n, then only we will apply root test, otherwise we will apply ratio test. Then apply the conditions of the ratio test or root test and check the convergence at x is equals to 1, right, whenever the test fails, and apply other types of tests such as limit comparison test, etc. Okay, so I hope you have understood throughout the session. Thank you for watching.